So Monday, day 2 of Unit 7, just finishing off the notes packet. Actually, this is exactly what we just did, except there's a sign there. Exactly meaning gives us a second derivative and wants us to underivative to get back to the original function. So let's underivative both sides. Again, that's not an official word, but people would know what you're talking about. So the antiderivative of the second derivative gets us back to the first derivative. How about the antiderivative of sine? What function has a derivative of sine? Good. Negative cosine. Negative cosine of x plus c. So let's use our first derivative information. So the first derivative is equal to 1 when x is equal to 0. Cosine of 0. That's another one where people get going quick and they just say, oh, you evaluate anything at 0 and you get 0. You're like, no, you don't. What's the cosine of 0? 1. So c equals 2. Alright, so f prime of x is negative cosine of x plus 2. Some people will try to skip this step. And I get it. It feels like, I'm just rewriting the whole equation and all I'm doing is plugging in 2 for c. And I get it. But if you skip that step, the trouble is, I'm not telling you not to. You can still do it. You can still skip that step. The trouble is people forget to integrate the 2. Like they do everything right, and then if they don't write this step out, they'll integrate f prime and get f. Antiderivative of negative cosine is negative sine, and they'll stop there because they forgot to include the 2. So I think it's worthwhile to write out that middle step, but if you want to risk it, knock yourself out. What's not right about my answer, or this step? It's not my final answer. Plus c. Now, people don't usually forget the plus c on these type of problems because they've already seen this, and so if their brain's turned on, they know that that's there to help them find the plus c. So if they leave off the plus c, then they're like, well, what do I do with that? And then you realize, oh yeah, there's a plus c supposed to be there. So plus c is more often forgot when there's not stuff to plug in. Like when this is your final answer, that's when people forget it. When there's more to do, I guess people, if they do forget it, they realize that they need it to use that last piece of information. So c is 6. So f of x, negative sine of x, plus 2x, plus 6. I think we addressed this last week. The 2 c's are not the same thing, but since you find one and then you're done with it, it's okay to use c for both of them. If that bothers you, then when you hit the second one, call it c2. Nothing wrong with that. If you need that to do that to help keep them straight. But if you solve for one and then move on, it's like I'm done with this c. This is a different c altogether. So that wasn't really even a new problem today. That was just more practice. Back to the worksheet page. Back and forth we go. I do want to put a couple of things at the top to remind you. They're old things, but maybe that's why we need to say them, because they're old things. Sine squared plus cosine squared is 1. You would probably remember that one. Do you remember how to get to the other 2 things? Like there's 2 other trig identities that are related to that one. How do I get the other ones? Assuming you don't have them memorized. Okay, move things around. But it's not enough to just like move things around. Do you remember what you have to do to get the other ones? Let's divide by sine squared and see what we get. Sine squared over sine squared is 1. Cosine squared over sine squared would be cotangent. And 1 over sine squared would be cosecant. Well, I bet with that clue you can figure out how to get the last one. What should we do to get the last one? Divide by cosine squared. Divide the original by cosine squared. So sine over cosine is tangent. Cosine over cosine is 1. And 1 over cosine is secant. So 3 trig identities that you hadn't seen in forever. AP test, College Board will definitely expect you to know sine squared plus cosine squared is 1. There'll be a problem on there somewhere where that's thrown in there. The others are less likely, but it's easy to get once you know the first one. Okay, speaking of review, what's the derivative of e to the x? Lauren, say it. E to the x. It's the one we like. Okay, so then what is the antiderivative of e to the x? Also e to the x. Almost. Plus c. All right, one more reminder and then we'll work through some of the worksheet together. How about the derivative of 3 to the x? You remember how that's different than e to the x? What's the derivative of 3 to the x? It's really similar to e to the x. It's got a little something extra there, though. There's a natural log in there. Do you remember where it goes? Well, it doesn't really matter if it's at the beginning or at the end. What matters is that it's multiplied. So, yeah, people put it different places. 3 to the x times natural log of 3. Okay, then what do you suspect the antiderivative of 3 to the x is?
Something over ln 3.
Yeah, that ln 3 is going to be in the bottom now because we're doing the opposite of derivatizing or anti-derivatizing. And 3 to the x just stays 3 to the x. And then the plus c. So the e to the x one's pretty easy because the derivative and the integral, it's all e to the x. No big deal. The 3 to the x has that extra natural log 3. It shows up multiplying if you're taking a derivative. It shows up dividing if you're taking an antiderivative. But again, that makes sense. Derivatives and antiderivatives are opposite functions. They undo each other. They're inverses. Multiplying and dividing are inverses. So they sort of undo each other. All right, 1 through 6 should be straightforward review. So you do 1 through 6 right now, and then I'll pull some popsicle sticks to check on those. Answers there for our viewers at home. There's the first 6. Again, those are the 6 basic trig functions. If you know their derivatives, then you can go backwards to get those answers. All right, next try 7 through 9, and I'll pull some popsicle sticks for those. Number 11, though, is a little bit different because if you think of it as 7, 8, and 9, you're like, okay, the antiderivative of 1 is x, that's easy. The antiderivative of tangent squared, that's not one of the ones that we know. So I'm kind of stuck unless you realize something that's going on here. What is tangent squared plus 1? Secant squared. That was one of the identities that we reviewed earlier. So a little bit of trig there, a little bit of pre-cal thrown in. And then the antiderivative of secant squared, that is one we know. Tangent has a derivative of secant squared. So tangent of x plus c. So that one was a little weird because it wasn't as straightforward as the others. We had to do a little bit of pre-cal to start with. 11 and 12 also have a little bit of pre-cal. I would just say on 12, pair those two. So try 11 and 12.
I don't really know what to do. I just did cosine squared of x to the -1. And then I don't know how to.
Yeah, you would be kind of stuck if you did that. Which is why you were stuck. So what is 1 over cosine? What's another way?
Oh, secant.
So this is secant squared.
You're so lost.
And then, Kylie, I bet you know the antiderivative of secant squared.
Yeah. Tangent squared plus 1.
Wait, careful.
Wait,
That's the same thing. If you put tangent squared plus 1, you're right, secant squared is the same thing as tangent squared plus 1. But I want the antiderivative of secant squared, which is tangent of x plus c. Yeah, 12 is a little trickier because you're like, well, how do I, who goes with who? How do I pair these up? But Alan, what's sine over cosine? I gave you a hint on this one. Sine over cosine is tangent of x. And then hopefully you've driven backwards enough to recognize, like, wait a minute, that's one of the ones I'm supposed to know. So Alan, what's the antiderivative of secant x tangent x? Negative. Wrong one. That's right. Secant of x plus c. Derivative of secant is secant tangent. So again, you got to know those forward rules well enough that you recognize the backward situation. Because normally you're like, wow, that looks complicated. You're like, well, yes, except that it's one of the ones we're supposed to recognize. Yeah, we're good on time. 13 through 16, and then I'll be done. So we'll have half the worksheet done before you leave today. So knock out 13 through 16, and we'll pull popsicle sticks for those. All right, Mia, what's the antiderivative of all of that stuff? All right, shh. What was it? What is it? What's the power of x going to be? So I'll increase the power by 1. Up the power by 1. That gets me 3/4. I don't want to divide by 3/4. I'd rather multiply by 4/3, which would give me a nice simplification, but I can also just leave it. And then I think I saw you had this part right. What's the antiderivative of cosecant cotangent? Negative cosecant x plus c. And again, that's an easy fix on the front one, but you don't have to make the fix. All right, Tyler. The antiderivative of 7e to the x?
I got a.
Yes, I would agree. Because the 7 doesn't really matter. You can just set that aside. And then the antiderivative of e to the x is e to the x. All right, Bryce. Similar problem, but you got a 5 thrown in there. So what is it? Good. It's 5 to the x, but there's a natural log 5, and since we're antiderivating, we'll anti-multiply, which would mean divide. So C. All right, so your job is the back page. How many are left? You got 2 nights to do 6 problems, right? Because you're off tomorrow. So some of you still won't do them by Wednesday, but again, you need the practice driving backwards. So try those last 6 before Wednesday to keep your practice up. Your backwards driving.